Hello and welcome to the another session of trigonometry. So in this session we'll start with the trigonometric ratio. So right angle triangle. So let's make a right angle triangle. So suppose consider this is a right angle triangle where 90 degree at A. So sorry, at B. So I'm writing here A. This is B and this is C. So B at this point, like if you see, this is what right angle triangle, symbol of right angle triangle. So opposite to right angle is always known as hypotenuse. So this is hypotenuse, and if you are going to take either of the angle, like suppose if you take this angle or this angle, that depend on us. So considering in this situation I am taking this angle is theta, which is, so in this case this will be our adjacent. Okay, so adjacent is this one, and opposite to the theta is always opposite. Okay, so from here, like we can say, in a right angle triangle, if there is a right angle triangle and at angle B, if it is 90 degree, then opposite to the 90 degree is always hypotenuse side. Adjacent to the angle is always known as adjacent side, and opposite to the angle is always known as opposite side. We can also denote, like if you want, you can denote it by ABC, or like hypotenuse is like H. If you want to denote by B, base, and this is what P, perpendicular. Then according to the Pythagoras theorem, we can write square of hypotenuse is equals to sum of the square of other two sides. That means this is what a Pythagoras theorem. We already have another session and I uploaded the video. You can go and check for the Pythagoras theorem. Okay, so this is Pythagoras theorem, where we can say in a right angle triangle, square of hypotenuse is always equals to the sum of the square of other two sides. Now we will discuss about trigonometric ratio today. So trigonometric ratio, there are sine theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. These are the trigonometric ratios. Now how we can identify or find the values of each? So there is an option, we can say, so there is a trick, we can say so ka tova. Okay, so this is so ka tova. Now if we'll see here, S stand for sine, C stand for cos, and T stand for tan. Okay, now OH, O is nothing but opposite, H is hypotenuse, A is adjacent, H is again hypotenuse, T is tan theta, tan, O is opposite, and A is adjacent. So ka tova, this is the simple way you can remember it. For sine theta, we can write SOH. That means it is nothing but opposite upon hypotenuse. Okay, so we can write O upon H. Okay, now cos theta is similarly, we can write adjacent upon hypotenuse. So adjacent upon hypotenuse. That means A upon H. Now tan theta, if I have to write here, tan theta is equals to what we can write here? OA. That means opposite upon adjacent. Okay, so this is what opposite upon adjacent. So we can write here OA, opposite upon adjacent. If I have to write like O, what is opposite? If you see here P, so this is P upon H, hypotenuse is H. This is B upon H. This is P upon B, like this way. Now cosec, sec, and cot. So cosec is nothing but it is what reciprocal of sine theta. So whatever the sine theta you got it, like you have sine theta is like opposite upon hypotenuse. That means P upon H, you can write here H upon P. That will be our cosec theta. And sec theta will be 1 upon reciprocal of cos theta. That means we can write here H upon B. And cot theta is reciprocal of tan theta. So we can write here 1 upon tan theta, which is going to be, yes, correct, B upon P. So like this way we can express or find the value of trigonometric ratios. So in trigonometry, main thing is like how we can identify the missing sides or missing angle. That is main purpose of the trigonometry. And when we deal with the trigonometry, first of all, if there is a right angle triangle, if you'll see, then opposite to right angle triangle is always hypotenuse. Then there is opposite to angle is opposite and then adjacent. Pythagoras theorem will come into the picture, where the square of hypotenuse is equals to sum of the square of other two sides. Sin theta, cos theta, tan theta, that we will use this rule, which is SOH, TOA, CAH and TOA. And cosec, sec and cot theta are reciprocal of sin theta, cos theta and tan theta respectively. So like this way we can say these are the trigonometric ratio. Okay. Now moving to the next one, trigonometric values. How we can find the values of the trigonometry. Okay. So I'm just writing here, like suppose the theta is like 0 degree, 30 degree, 45 degree. Okay. Now 60 degree, 90 degree. If you want, you can write for 180 as well. Standard values how we can find out. So I'm going to write here sine, okay, then cos, then tan, and then we know we have to take the reciprocal of all other, right? So I'm writing here cosec, then sec, and then cot theta. So these trigonometric values how we can find it. In radian, how we can convert? So this is in degree. If we have to convert, like suppose this is what 30 degree, I am writing here degree to radian. How we can convert? Okay, so first thing is like if there is a 30 degree, how we can convert? So 30 into pi upon 180. Like this way, if you multiply a degree with pi upon 180, then you can convert degree into radian. So 30 into 1, 30 into 6. So answer will be pi upon 6. This will be 0. This will be pi upon 6. Pi upon 6, my bad. This is pi upon 4. This is pi upon 3. This is pi upon 2. And this is what? Pi. And if you want to convert like radian to degree, r to degree, I am just writing in short. Okay. So radian to degree, how we can convert? Like pi upon 6. Just replace the value of pi with 180 degree. 180 degree upon 6. You'll get into the radian. So like this way, we can convert degree into radian and radian into degree. Now let's come for this, how we can find the value of each trigonometric ratios for each of the degree, like 0, 30, 45, 60, 90 and 180. So first of all, what we have to do, my bad. Okay, let me erase it and then we will write it again. Okay, so see, sine 0 is always 0. I'm going to write here. Sine 30 is half. Okay, sine 45 is 1 upon root 2. I'm writing and then we will see how we can find out. Then root upon 3 2, root 3 upon 2. Sine 90 is 1. Again sine 180 is 0. Okay, so what was confusion here? Like I wrote it like this way, right? So I have to use eraser. So I'm just erasing it. Okay, that's why I was not erasing it. Okay, now let's do it once again. So start. So this is, so first of all we have to write here 0. Okay, here like 1. Okay, here like 2, 3 and 4 and then again 0, because it's like, or you can, now what we have to do here, we have to divide each by 4. Okay, so first thing is like write 0, 1, 2, 3, 4, then divide by 4. So I'm writing here 4, 4, divide by 4, divide by 4, divide by 4, divide by 4. And then take the square root of the value. Okay, so like this way we can find 0 upon 4. Okay, now if you see here 0 upon 4 is 0, square root of 0 is 0, 1 upon 4, right? Square root of 1 upon 4 is 1 upon 2. Now this and this I will cancel it. I will write 1 upon 2 and there is a square root, so 1 upon root 2. Root 3, root 4 is 2, so I will write here 2. 4 upon 4 will cancel, answer will be 1 and this will be 0. So like this way we can identify the value of sine theta. Okay, this is a easy trick. 0, 1, 2, 3, 4 you can write and then you can divide by 4, then take the square root of the value. Now cos theta, cos 0, start from here. Okay, write like this is 1, then root 3 upon 2, then this is 1 upon, it's going to be same, then 1 upon 2, and then 0. Cos 180, see 180 I didn't want to write, but if you want to write, you can write it. This value will come like -1. Why it will come, I will explain you later, because it comes into the second quadrant. In the second quadrant, the cos theta value will be negative. So I will explain you that part. Okay, so you can leave for this one, or we can see here like sine is like going like this way, maximum is, see if you plus 1, sine this is, it's going, and cos if you'll see, cos is like going like this way. Okay, so graphical representation we'll discuss later, but the here like what we can write here, cos 0 is 1, cos 30 is root 3 upon 2, like. Now tan theta is like just divide by this 2. 0 upon 1 is going to be 0. If I will divide this one, I will get it, because tan theta we know sine upon cos, right? So we have to just divide the value. 1 upon root 2, 1 upon root 2 is going to be 1. Root 3, 1 by 1 cancels, so root 3. 1 upon 0 is going to be not defined, so I am going to write here not defined, or in 0 upon -1 is going to be 0. Now cosec is what? Reciprocal of sine, so this is 0, that means this is 1 upon 0, which is going to be not defined. This is going to be 2, this is going to be root 2, this is going to be 2 upon root 3, this is going to be 1, and this is going to be 1 upon 0, which is going to be infinite. Sec theta is going to be reciprocal of cos theta, so I will write here 1, 2 upon root 3, root 2, 2, this is 1 upon 0, that means infinitive, and this is what, -1. Cot theta is again reciprocal of tan theta, so that will be infinitive. This will be root 3, this will be 1, this will be 1 upon root 3, and 1 upon 0, that means 0 upon 1, answer will be 0, this is 0, so this will be infinity. So like this way we can find the trigonometric values. Okay, so pardon me for the first step which I like missed, but this way you can find out the values of each trigonometric ratios, for these are the standard angles. Okay, now moving to the quadrant which I was highlighting, right? So this is like when we divide any plane into the 4. If you see, this is what the 4 x-axis and y-axis divided into the 4 quadrant. This is going to be the first quadrant, this is going to be second quadrant, this is going to be third and fourth quadrant. Now in the first quadrant we know x and y both are positive, sine is positive. Here like x is negative, y is positive. Here x and y both are negative, and here like x is positive but y is negative. This is an algebra, right? Now here like angle, if you'll see, it is what going to be 0 to 90, less than 90, right? So angle is like 0, greater than 0. Theta is greater than 0 but less than 90. Here like it is greater than 90 but less than 180. In this case it is going to be greater than 180 but less than 240, and then 240, it is greater than 240 but less than 360. Okay, sorry, 270, my bad, 270. Okay, so this is like how we can divide the quadrant. Now coming to the trigonometric ratio, in the first quadrant all trigonometric ratio are always positive. Either it is a sine, cos, tan, anything. All the trigonometric ratios are always positive in the first quadrant when the angle is in between 0 to 90 degree. In the second quadrant, when the angle is between 90 to 180, then that time we can say sine theta and cosec theta, except these two, rest all are negative. That means sine theta and cosec theta will be always positive, rest all the trigonometric ratios will be negative. Okay, now in the third quadrant, when we discuss about the third quadrant, that means the angle between 180 to 270. Okay, so in that scenario tan theta and cot theta are positive, rest all the trigonometric ratios are negative. In the fourth quadrant, where the angle is in between 270 to 360, here's cos theta and sec theta are positive, rest all the trigonometric ratios are negative. So this way, like quadrant wise, we can identify in which quadrant the trigonometric ratios are positive, in which quadrant the trigonometric ratios are negative. Now moving to trigonometric identities. So there are few important identities which we need to remember in order to solve any trigonometric question. So there are some standard one, which is like first sine square theta plus cos square theta is equals to 1. Sometimes we can write like cos square theta is equals to 1 minus sine square theta. Also we can express like this, like we can bring, or we can write here sine square theta is equals to 1 minus cos square theta. Either of these three. Okay. Now there are few other which is like in between, like if sine theta is there, now relation between the sec theta and tan theta. So sec square theta minus tan square theta is equals to 1. Or we can write here sec square theta is equals to 1 plus tan square theta. Okay. Or we can write here tan square theta is equals to sec square theta minus 1. This is another set of the trigonometric identity. Third one is like between another cosec and cot. So we can write the similar way, cosec square theta minus cot square theta is equals to 1. And we can write another way, cosec square theta is equals to 1 plus cot square theta. Or we can write here cot square theta is equals to cosec square theta minus 1. So this is another set of the values. So like these are the three important set of trigonometric ratios, identity, which we need to remember. 1, 2 and 3. Sin square theta plus cos square theta is equals to 1. Sec square theta minus tan square theta is equals to 1. And cosec square theta minus cot square theta is equals to 1. Now complementary and supplementary angle. If the sum of two angles is equals to 90 degree, we can say this is what complementary angle. And if it is sum of two angle is 180 degree, then we call it a supplementary angle. So let's start with complementary, then we'll check for the supplementary. I missed to write supplementary angle. Okay. So complementary angle. So there are a few examples I'm just taking. If I'm going to write 90 minus theta, so it is what, less than 90, right? If I subtract anything in the theta, that will be always less than 90. That means it will come into the first quadrant. That means complementary, the value like sine will become cos, cos will become sine, tan will become cot, or cot become tan. But if it is in first quadrant, the value will be positive. Like if I write here cos 90 minus theta, then in that scenario what we can write here? Sine theta. Okay. Now let's take one more example of sine cos, then tan 90 minus theta. Answer will be cot theta, because it is complementary angle. If we are cot 90 minus theta, what we can write here? Tan theta. Like sec 90 minus theta, we can write here cosec theta. And if I write here cosec 90 minus theta, then our answer will be sec theta. Okay. So this is first. If there is a plus sign, then what will be the changes? If there is a plus sign, that means it will comes under the second quadrant. Now you have to think, in the second quadrant, if we'll go back to my previous slides, in the second quadrant only sine, the value of sine theta and cosec theta will be positive. Rest all, whatever the value will come, it will be negative. If there is 90 plus, sine 90 plus theta, it will be cos, but rest all, like it will be plus, but rest all will be negative. So tan 90 minus plus theta minus cot theta, cot 90 plus theta minus tan theta, sec 90 minus plus theta minus cosec theta. Like this way we can find the complementary angle. Now supplementary angle, if I will write here sine 180 minus theta. So in supplementary it will not change. Sine will be sine only, but we have to just check which quadrant it is. If it is in first quadrant or second quadrant, third quadrant, fourth quadrant. 180 minus theta, theta is like acute angle, that means less than 90 degree. That means if it is like 30 degree, 150 it will come, right? That means it is coming into the second quadrant. In the second quadrant, sine will be positive, rest all will be negative. So cos 180 minus theta, if there will be, our answer will be minus cos theta. Tan 180 minus theta will be minus tan theta. Okay. So like this way, cot 180 minus theta will be minus cot theta. Okay. So like this way, if you see this is not going to be changed. Sine will be sine, cos will be cos, tan will be tan. Only the sign will change because of the quadrant. So that's why the quadrant was important. That's why I explained in the previous slides. Okay, so this is like how we can find the complementary or supplementary angles. Sine 90 minus theta, if there will be cos theta. If there is a sine 180 minus theta, then there will be sine theta. So that was the difference. Okay, now moving to the double angle formula. Couple of angle formulas like double angle or triple angle. So in this session I am going to only take double angle formula. So sine, there are a couple of important 2 theta. So I can write a 2 sine theta into cos theta. If there is a cos of 2 theta, then cos square theta minus sine square theta. Or we can write here like sine square theta plus cos square theta. If you know the identity, we can use here and then we can identify and we can convert into 1 minus 2 sine square theta, or we can write 2 cos square theta minus 1. Either of these three. Okay. Now similarly for tan 2 theta, that will be 2 tan theta upon 1 minus tan square theta. Now how this comes? So there are a couple of formulas which also we need to remember. Based on that we can identify these values as well. Okay, so which is known as angle addition formula. So we can use that and we can identify the values of double angle or triple angle, whatever. Like suppose example is like angle addition is like sine A plus B. I'm just taking one example like sine A plus B is equals to sine A into cos B plus cos A into sine B. Now let's take one example like sine 2 theta, right? If I say 2 theta, that means what? Sine A plus A, that means theta plus theta, correct? Put it here and check. So sine theta into cos theta plus cos theta into sine theta, right? So sine theta into cos theta, sine theta into cos theta, 1 sine theta into cos theta, 1 sine theta. That means it is going to be 2 sine theta into cos theta. So if you see, compare with our previous slide, sine 2 theta is going to be 2 sine theta into cos theta. So that's why the angle addition formula is also important. If you know, you can identify for 3 theta as well, 4 theta as well. Okay, so like this way we can find the values of using the angle addition formula. So there are like, if there is a plus, if there is a minus, if suppose if there is a minus b, there will be a minus b. Similarly for tan, if I have, for cos, if I have to write cos A plus B, in that scenario we have to write a cos A into cos B minus sin A into sin B. Okay, if there is a minus sign, let me highlight with the other pen. So if there is a minus sign, then there will be a plus. So like this way we can write. Now if there is tan A plus B, then tan A plus tan B, okay, upon 1 minus tan A into tan B. Okay, so like this way, if we have like a minus sign, then here it will be minus and this will be plus. So like this way we can use the angle addition formula to identify the values as well. Okay, so this was all about the basic trigonometric